So another important aspect of reporting accurate data, in addition to getting the precision and the accuracy correct, is also to report your numbers using significant digits. So what are significant digits? So a lot of you, when you type numbers into that's not good. When you type numbers into a calculator, you get these really long answers. Maybe it's 1.8762947, right? You get these really, really long numbers, but you couldn't possibly know the numbers that you are measuring to this many digits of significance or accuracy, or this precision, I mean, with most measurement instruments we're going to be dealing with in this class. And so we use what we're going to call significant digits. So the number of significant digits that you report should reflect the precision of the value or the input data of your calculation. So let's talk a little bit more about this. How do I know if a digit is significant or not? So the way you can tell if a digit is significant is by using some basic rules to count your number of significant digits. So first rule, all non-zero numbers always are significant. So for example, if I have 1, 2, 3, 4, 5, 0, I have 1, 2, 3, 4, 5 significant numbers, and I don't count this 0. So I have 5 significant, I'll just write sig figs, significant figures. Alright. Second rule, number 2. All zeros between non-zero numbers are significant. So this 0 right here was not significant. However, if I have a number 1, 2, 0, 4, 5, this 0 right here is significant because it's in between two non-zero numbers, the 2 and the 4. So I have 1, 2, 3, 4, 5 significant figures again, 5 sig figs in this example. Okay, third rule. There's only 4 rules, I promise. Third rule, all zeros that are both to the right of the decimal and at the end of the number are significant. So if I have a number, for example, I should write a number in here, otherwise there's no significant figures there. So if I have 0.0010, okay, so all the zeros to the right of the decimal and at the end of the number are significant. So that means that these zeros right here are not significant because they are not to the right of this number, but they're not at the end of the number. But however, this 0 is significant. So I have a non-zero number 1, which is significant, and a 0. So I have 2 sig figs for this number. Okay, last rule before we get into some math. All zeros written to the left of the decimal point are significant. So if I have a decimal and I have to explicitly have written the decimal, if you had, for example, like I showed you in number 1 here, where there's no decimal point, this 0 is not significant unless I have the decimal point. So let's look at this. So I have 1, 2, 3, 4. 1, 2, 3, 4. This 0 is significant because it's to the left of the decimal point. And 5. So I have 5 sig figs again. And that's all the rules. Okay, so now what do we do if we're multiplying and dividing or adding and subtracting different values we collect, and all these values are going to have different amounts of significant figures. So for multiplication and division, it's really, really simple what we do. We just take the number of sig figs must not exceed that of the least precise value upon which it depends. So if I take, for example, 10.3 meters, and I divide it by 1.2 meters, I get this really long number, 8.5 8.583333, and this 3 goes on and on and on forever. But then I look and I have to find the least precise value I have. So I have 3 sig figs here, sig figs for this one, and I have 2 sig figs for 1.2 meters. So I can only have 2 significant figures in my answer. So this number here, 8.5, I did it again. This number 8.583333 meters has to be shortened to 2 digits. So I have 8 and I have 5, and I'm going to keep those. And my next digit here is an 8. So therefore I'm going to round this 5 up to a 6. And so my real answer is not this, it is 8.6 meters is correct. Okay, so what if I'm adding and subtracting? So adding and subtracting is also quite easy. It's a little bit harder, I guess. So when we're adding and subtracting numbers that we need to report significantly, the answer can have no more decimal places than the least accurate measurement. So I have an example here at the bottom. So 150 grams, let's say I take 150 grams of water and I add it to 0.057 grams of salt, and I get a number, in my calculator number is 150.507 grams, but this has way too many sig figs. So let's see how many sig figs we can have. So we can have no more than the least decimal places of the least accurate measurement. So I can have no more decimal places than the least accurate measurement. So I have 1 decimal place here, and I have 3 decimal places here, so I can only have 1 decimal according to this. So I'll get rid of this number, and I'll report my true value as 150 and 1 decimal place, 50.5 grams. Alright, so no more decimals than the least decimal places you have. Okay, so what about rounding? So I probably should have told you this earlier. So if you have to round, we do not round down when we make something into significant digits. So if the number that you're eliminating is less than 5, you just drop the digit and you leave the next number unchanged. However, if the number is greater than 5, then you can drop the digit and add 1 to the next digit, like we did in the multiplication example. Alright, that's it.